In learning objective B, they're going to ask us to verify that two functions are actually inverses of each other. What you're going to want to be tempted to do for f of x here is, one, realize that it's the equation y equals x plus 3. And then that g of x here is again just y equals x minus 3. I will tell you, if you put them on graph paper, again, we just talked about this, there's a line they'd flip over. If you graph them, you will see a visual flip over that black line. And that's great for a gut feeling, but it's not verification or a mathematical proof. You must mathematically prove it. And to do that, we have to go back to section 7.4, function composition, and you have to show this. You have to show f of g of x equals x, and then you flip it that g of f of x equals x. And you're trying to make sure it equals x. They can't equal 3x, 4x, 0, it must be x. So basically just do function composition 2 times, and if it works for both, you come back and say yes, they are inverses of each other. So let's go ahead and get started. I'm going to do f of g of x first. And I'll do 2 different methods for it. Substitution first. I'm going to take g of x, which is x minus 3, and put that in there. So f of x minus 3. Now remember, it tells me here, go to the f function, so I eyeball this. Wherever you see x, put that in its place. So that's going to come out of the function, and in its place, I'm going to put x minus 3. So it used to be x plus 3, but instead of x, I put this, x minus 3. If you simplify this, you get x, which tells me the first side is right. Now, I have to do the other function composition, and this one must also work. Otherwise, if one works but the other doesn't, they're not inverses of each other. So let's flip it, g of f of x. This time I'll just jump right into it. I'm going to take the f function and just plug it right into the g. So I come up here, here is the f function. I'm going to plug it right into g where x exists. So I'm going to take this guy out. So normally it was x minus 3 is what the g function was. F of x is x plus 3, so I plug that in there. Simplify this, it's x. They both equals x, so I would answer the question, yes, they are inverses of each other. This second example is worth looking through because we are going to deal with some fractions, so a little bit trickier in function composition, but very doable. So if you want to stop and pause the video and try it, otherwise let's jump right into it. Let's find f of g of x and g of f of x. So f of g of x, I'm going to take the g of x function, which is this right here, and I'm just going to substitute it for now. Now at this step, it tells me to go to the f function, which is right here. Wherever I see x, put this in its place. So I'm going to replace that with the x. Just be careful here. 3 times, not x, but this right here, 1/3 x plus 5/3. And then don't forget the minus 5. I'm going to come in and distribute the 3 through. That's going to give me 3 over 3x, which is 1x. This is going to be 3 times 5, which is 15 over 3, minus 5. If you simplify this, this would be x plus 5 minus 5, which will equal x. So the first function composition works. Let's see if it does in reverse order. Let's do g of f of x. I'm going to take the f function here, and I'll just shortcut this one. So it says eyeball the f function, which is right here. Take that and go plug it into the g function. So I take this, and I look where the x is in the g, and I put it right there, and I substitute. So instead of 1/3 x, it's 1/3, 3x minus 5 in parentheses, and then plus 5/3. And I'm going to distribute the 1/3 through. This will be 3x over 3, which is 1x. So it'll be negative, or 1 times negative 5, which is negative 5/3, then plus 5/3, and this just clears out to x. So yes, they are inverses. Now again, I could verify it graphically, which is more for our gut check here. This is the line y equals x. If you were to graph these, and this is good practice, so let's go ahead and do the original one here. Remember, the y-intercept is 5. -5 actually, which is right here. The slope is 3, or 3 over 1. So I'm going to go up 3 over 1. It'll be something like that. It's kind of a sloppy line, sorry about that. Let's do this one. The y-intercept is 5/3. 5/3 is going to be 1 2/3, which is about, in your calculator, 1.67. So the y-intercept is going to sit about right there. The slope is going to be up 1 over 3. And if you sketch that, it's going to look like this. Now, technically, I can tell you, this does work. I think my red and the blue line could be both a little bit better. This is probably going to cross more like here, and you will end up seeing it flips. And you could just use a graphing calculator at this time to check that too.